Well, welcome to MV Tutors. My name is Figa. If you would like a tutorial session after this, you can go and book one on our website www.mvtutors.co.za. Alternatively, you can comment on this video asking for one and we'll give it to you gladly. Now, I like to start my sessions with a vision. And what's a vision, you say? It's basically just a past exam paper. The question that we are dealing with today has to do with sketching cubic graphs. So today we'll be doing a lesson on cubic graphs. Now, you can just look at this question very quickly, and if there's a part of it that you don't understand how to do it, then stick around. We're going to learn the principles in order to answer these types of questions. Okay, so let's get right into it. So a cubic function f of x is given by ax cubed. That's what actually makes it a cubic function, because the variable x is cubed. And then the rest of it, the rest of the equation is bx squared plus cx, well, you can put a 1 or not, plus d. That's the normal general formula of a cubic function. Now, there's two types of cubic functions. There's a positive one, which is given just by if a is positive, ax cubed. If it's positive, then the graph, it's all about the ending, okay? It starts with a sad face, but it ends up smiling. Okay, so that's the smiley part. If a is negative though, then it's all about the ending, okay? So it starts out smiling and then ends up sad. It all ends in tears for the negative graph. Okay, now there's a few things that you need to we need to establish here. Is that number one, we have x values. Okay, so we have x values 1, 2, 3 at the most. You can have a situation where you have 2 x values and also 1 x value, depending on how the graph moves. Also, what we have with a cubic graph is that we have turning points there. So these ones, we call them the turning points. Okay. And then we also have this one here in the middle of the turning points. This is what we call the point of inflection. Okay, we'll get to see how we solve all of those. And then additionally, we have a y-axis point, y-intercept rather. Okay, now let's talk about solving the actual points that you need to draw this graph. The first one is the y-intercept. Okay, now to get the y-intercept, basically you just say x is equals to 0, and then you solve the y-intercept. Most of the time, or all the time, it's just going to be your d. That's going to be your y-intercept. And then to get your x-intercepts, that's where it gets a bit dicey. Now, you say you let your y equals to 0 as well. Okay, and then there are many ways then you can solve that. One of the ways you can solve that is by simply just factorizing. Okay, so you can just simply factorize, or you can use long division. You can use a long division method to solve those x values. We have done a video lesson on long division, so you can check that out. Or alternatively, you can use what we call synthetic methods. Synthetic methods. Okay, so there are many kinds of synthetic methods. We do have a video as well on synthetic methods, so you can check that out as well. Okay, so that's how you get your x-intercept. So it's these values there. So y-intercept over there, x-intercept over there. Okay, now we've got those points that we need. Now we need to get into the turning point and the point of inflection. To get your turning point, okay, your turning point, or let me say turning points, what you have to do, you take the first derivative, okay, of the function and you equate it to 0. And then this is going to give you the x value. Okay, that's going to give you the x value of the turning points. And then to get to the point of inflection, okay, what you have to do is take the function and get the second derivative, equate it to 0, and likewise you get the x value of the function. Well, obviously you have to take the x values now and put them into the original equation in order to get the coordinate in xy, in order to get the x and y. So these derivatives, they're just giving you the x's. Now to get the y components, put it in the original equations. So the last part that I want to discuss is the concavity. Okay, the concavity of the graph. Now let's take a positive graph. Started out sad, but it ends up smiling at the end. Nice. Now when the graph is sad, okay, we call it concave down. It's feeling down. And concavity, it only ends at the point of inflection, because at the point of inflection, that's where it starts changing. That's where the change is made, where it stops being sad and then it starts being happy. Okay, and then we call it concave up when the graph is smiling. Now the graph is increasing when it's moving up. Now you always come from the left. Okay, pretend you're driving a car from the left, and then once it hits the graph, it starts going up. Okay, when it's going up, we call it increasing. Okay, it's increasing. But once it starts going down, okay, and it changes from up to down at the turning point. Once it starts going down, then we call it a decreasing. It's decreasing, or it's being a decreasing function at that point. So it increases, decreases, and increases again. That's how we categorize those things of concavity. Okay, now I think we're ready to answer our visionary question. Let's get into it. Okay, here we go. Now, check this out. 9.1. Let's say write down the coordinates of the y-intercept. What did we say about the y-intercept? We said when you're solving the y-intercept, you let x equals 0. So you take the function, okay, it's y is equals to x cubed minus x squared minus x plus 1. Now, if you let x equals 0, you're going to have 0 there, minus 0, minus 0, plus 1. So y is equals to 1. Now, because the question wanted a coordinate is given in terms of x and y. All we have right now is the 1. But since we said let x equal 0, because the y coordinate is where x is equals to 0. Okay, now let's do 9.2. Now what do they want in 9.2? Calculate the coordinates of the x-intercepts. So they want the x-intercept. Okay, what did we say about it? We said you let y equals 0. Now if we rewrite the equation, we're gonna say 0 is equals to x cubed minus x squared minus x plus 1. Okay, now there are different methods in order to solve the x, like we've discussed above. We said there's 3 methods. The first one is factorizing. If that doesn't work, then you use the long division. If that doesn't work, then you use a synthetic method. But you can just use any of them, in all honesty. Okay, let's see if we can factorize. First, let me look. Can I factorize here? Yes, I can. Okay, so I can use the grouping factorization. Okay, where I just look at these two, factorize them, and then I look at those two, factorize them on their own. So factorizing these two, I can see that the common factor between these two, the highest common factor rather, is x squared. And then to get x cubed, I need to multiply with x minus 1. Okay. And then this side, in looking this side, then a common factor between these two is just, let's say, it's minus 1. Okay. And then to get minus x, I multiply with x. To get plus x, multiply with a negative 1, because the negative 1 times the negative 1 gives me a positive 1. Okay, so as you can see, it's working out really nicely. Now I'm also going to look at these two terms once again. I'm going to look at this one as one term to factorize again, and then also look at this one in combination with the first one. So here, the common factor between these two terms, okay, is x minus 1, okay, and then I open bracket. Now, in order to get this term, the first one, I need to multiply with x squared. And in order to get this second term, I need to multiply with minus 1. Okay, so there we go. Now we can make it expanded, x minus 1. Now this second one here is actually what we call a difference of two squares, where the variable is squared, but also the value is also squared. Okay, so it means it's x minus 1, x plus 1. See that? Now, for the values of x, that means we're going to have x is going to be equals to a positive 1, and x is going to be equals to a negative 1. Now, we're not done, because the question actually wanted the coordinates. Okay, now coordinate, remember, is in form of x and y. So the coordinates are x and y. The first one we're gonna have is 1. Y is always gonna be 0, because we let y equal 0. And for this one, it's gonna be x is minus 1 and y is 0. There we go. Okay, now let's go to the next question, which is 9.3. Calculate the coordinates of the turning points. Okay, 9.3. All right, so what did we say about the turning points? We said turning points, you have to get the first derivative, okay, and then equate it to x in order to get the x values. That's what we said, right? So let's do that. Now, the original function f of x is equals to x cubed minus x squared minus x plus 1. Okay, if I remember correctly. Now, to get the derivative of this, if you don't know how to do derivatives, we have done a video lesson. You can check that out as well. But basically, we bring the 3 down, and then we say 3 minus 1, which is 2, minus, we bring the 2 down, and then it's x, and 2 minus 1 is just 1, and here it's just minus 1. Okay, so that's our function. So we need to equate this to 0. So we say, look at that, 2x minus 1, equate it to 0, and then solve for x. Now I'm just gonna go straight into the quadratic formula in order to solve this. If you remember it correctly, minus 4ac, okay, divided by 2a. Okay, so here, what is our minus b? What's our b? B is minus 2, plus or minus, b is still minus 2 squared minus 4, a is 3, and then c is minus 1. Okay, all of this is under a square root. It's all divided by 2a, it's 2 times, and a is 3. Okay, now what we're going to do is that we're going to bring out our calculator. Okay, now in our calculator, we're going to put it exactly as it is. So we have that. We have a negative and negative 2, close the brackets. Let's start with a plus. Okay, and then we'll put the square root, put the bracket, negative 2, close that, and then we square it, and then we have minus 4, that, close the brackets, open it again, put a minus 1, close it. Then we can go down, we have a 2, open bracket, 3, close it. Okay, so our answer is x, our first x then is equals to 1. Now let's go back here and change the plus into a minus. Let's see how that is affected. So our x is equals to minus 1 over 3. Now we need to convert these into coordinates, and to do that, remember, coordinates is x and y. It's x and y. Okay, now x we know is y, but because we know we've solved what 1 is, if x is 1, we know that y is going to be equal to 0. We solved it previously. What we're going to do here is that we're going to take, we don't know the y value of minus 1 over 3, so we have to put that into the original equation. Okay, so the original equation is x cubed minus x squared minus x plus 1. Okay, so all that means is that where there's an x, we're going to put minus 1 over 3 cubed minus 1 over 3 squared minus 1 over 3 plus 1. Okay, let's put this in the calculator. So we have a bracket, and then we have this thing. We have 1 there, okay, and then we have 3 there. All right, and then we close the bracket, square it, minus open bracket, we have a negative, we have a 1, we have a 3. Okay, we close the bracket, squared. Oh, sorry, that first one is actually this one. It should be cubed. It should be cubed. Yes, there we go. Okay, and then minus, we have an open bracket once again. Put that, -1. We come down here, we have a 3. We close the bracket. Okay, that one is not, it's neither squared nor cubed. And then it's just plus 1. Okay, so then our final answer is 32/27. So that means that our coordinate then, in terms of x and y is -1/3 and then 32/27. Okay, now let's check our next question, which is actually 9.4. Sketch the graph. All right. In sketching the graph, okay, I normally like to look what's the biggest x value, the smallest x value, the biggest y value. That will guide me on how to draw the graph. Now, if I look here, let me just convert this one into decimals because we don't want to work with fractions. So this one is 1. It's 1 divided by 3. That's 0.3. This one, the next one is 32 divided by 27. So that's like 1.2. Okay, so now that guides me to say my biggest y value is 1.2. Now I know that when I'm drawing my graph then, that my biggest y value is going to be, let me get a pencil, it's going to be y2. So here we go. All right, and then my biggest x values are also going to be, there we go. Okay, so now let's start with the y coordinate. The y-intercept, it was 0 and 1. So come here, go 0, 1. Let's make 1 over there. That's our y-intercept. Okay, so this point here is 0 and 1. Our x-intercepts, the ones that we solved here, is 1 and -1. Okay, so I know here it is -1 and 0. Okay, and over here I'm gonna have 1 and 0. Okay, and then for my turning points, which is these ones that I have my turning point, my first turning point here at 1, at my, wait a minute, no, it's at 1 and 0. Okay, and then my other turning point is -0.3, which is somewhere here, 1.2, which is somewhere here. That's the point. So this one is -0.3 and 1.2. Okay, now is this graph positive or negative? If you look at the original function, it's a positive graph, so I'm expecting it to start with a sad face, end up with a smile. Now I know that's my turning point there. That means, and that's my other turning point, so it starts smiling here. Okay, so my graph therefore is going like that, hits there, that's it. That's my 0. That's my other point. That's my other point. That's my other point. Okay, let's go check now what our final question is. It says write down the values of x for which f of x is less than 0. Now check this out. It says that the first derivative is less than 0. That means where the first derivative, that's actually where the graph is decreasing. Okay, where the graph is decreasing. Now, if we look at our graph over here, from here to here, it starts increasing. Okay, so let me get my red pen. If we're coming from this side, okay, it is actually increasing, and then from the turning point to 1 to the next turning point, that's where it is decreasing. So the way I write that is x, the values of x where this graph is decreasing is between -1/3 and 1. That's it. That's where the graph is actually decreasing. Or another way you can write it is that it's x is an element of, okay, this bracket, it means that it doesn't include 1/3, okay, and 1 doesn't include 1 as well, because it didn't say where it's also equal. But if there was an equal, then our brackets would have been square brackets. But because it's not equal, it is just normal brackets. Well, that's it. Thank you so much.